In this chapter, we're going to talk about dependency injection. Before that, let us try to understand the term tight coupling. Let us take a look at some of the real-world examples of tight coupling, thereby you'll understand better. So here from this image, we can say that the pillars and the building are both tightly coupled to each other. That's because, let's say that I found out that the pillars are getting old, and now I have decided to replace all the pillars. I can't replace the pillars alone without disturbing the building. That's because they both are tightly coupled to each other. But the point here is, if I'm making changes to pillars, that will have impact on some other entity. A human hair is another example of tight coupling. You can't pluck the hair from your head without hurting yourself. So plucking the hair from your head will have an impact on your body. Here we have the one last example of tight coupling. The cables of this bridge are tightly coupled to the bridge. If you cut down all the cables, that may cause the bridge to collapse. So what are some good real-world examples of the opposite, loose coupling? Spectacles. You can keep switching the spectacles depending on the color of your choice, and that will not have any impact on your body. So both your body and spectacles are loosely coupled to each other. Removing one from the other will not have any impact on either of the objects. Similarly, a mobile case would be a good example of loose coupling. A mobile case would be loosely coupled with a mobile phone. You can keep changing the skin as you wish. It will not have any impact on the phone. The phone would still function as usual. Now these are all some of the examples of tight coupling and loose coupling in real world. But how about programming? So let us see what is tight coupling in programming. Before that, let us try to understand the term software component. Just as we have a car that is made out of multiple components, for example, a car would have a component called engine, another component called steering wheel, and another component called gearbox, etc. When all these components combine together, we'll have the final product. Similarly, a software product is also a combination of multiple components. Now these components can be as simple as a simple class, or is combination of set of related files that together will solve a certain problem. I mean, just as with the case of a car, we have a bigger component which is the engine, which in itself has multiple other components, and we also have some minor components like a steering wheel, for example. And oftentimes these components are dependent on each other in order to function in a certain way. For example, in order for the wheel to rotate fast, you have to press the accelerator. So the component wheel is kind of dependent on the component accelerator. And similarly in software as well, we do have multiple components and are dependent on each other. What we're going to take a look at now is a very simple example of the same. So here we have a very simple example of a component being heavily dependent on another component. We have this Java bean inside which we're trying to instantiate the dog class, and the dog class has just one method in it which will ask the dog to make noise, and that's the method that we're trying to call from here. Now it's safe to say that Java bean is dependent on the dog class. Only then can it call its method. But we have a very serious problem. Let's say that I've decided to make noise like a cat. Now what should I do? I should go back to my bean and try to make changes in the code. I'm going to make this a cat and make those changes everywhere. And do take a note that this method is no longer valid. I need to use the method that is specific to cat, which is shout. Now this is a very simple example. Imagine that you're working on a real-world project. You'd have to make these changes in thousands of locations, which is of course not feasible. That's why we need to try our best to make these components as independent as possible, or in other words, We need to make sure that they're loosely coupled to each other, not tightly coupled to each other. So let's continue from next video and see the solution. In our previous example, we've seen that our class is heavily dependent on the dog class, and so we're not able to switch to an alternative. If we make this to cat, then rest of the code is breaking. So one way to solve this problem is by using interfaces. Let me explain you what I mean. So what I've done now is I've created this interface, animal, and both cat and dog would implement that interface. And these two classes would provide their own implementation for the method makeNoise. Now in my code, instead of explicitly mentioning the class name as dog, I'm going to make it more general and make it animal, and the method name in the rest of the code would also change with the method name makeNoise. Now that way I have the freedom to switch to alternative. For example, if I make this to cat, the rest of the code would still remain same, no changes are needed or whatsoever. But still, we didn't accomplish our goal of making this class and the cat class being independent of each other. So what can we do in here so that this class would be completely independent of either cat or dog? Can you make a guess on how we can fix that? Well, it's actually quite easy. All I'm going to do now is introduce a new constructor, a parameterized constructor, and the parameter that we're going to pass is going to be of type animal. We're not going to explicitly mention either cat or dog, but we're going to get more general and say the argument is of type animal. So let me show you what I mean. So I have this class in here, and I've defined a constructor that takes in the animal parameter, and I'm just trying to assign it to this variable. Now nowhere in this code did we mention cat class or the dog class. Now it's really safe to say that this class has no dependency, or in other words, this class is loosely coupled with cat or dog. But who is actually going to pass this argument? Well, it's from our main class, and all I'm trying to do here is I'm creating an instance of this bean, and then I'm trying to pass the parameter to its constructor. Now depending on the parameter that I pass, its corresponding method would be invoked. So in here I'm trying to pass the dog object, so that's going to result in executing this line of statement. If this was cat, that would result in executing this statement. So let's quickly run the program and see how things will go. And now let's make this as cat, save the file and run the program, and there it is. Now we've certainly accomplished something really significant in here. We didn't define the bean class dependencies in its class itself, but rather we have sort of sent its dependencies as a parameter to its constructor, or in other words, we're trying to inject the dependencies into this bean, and that's exactly what is called dependency injection. So by using the technique of dependency injection, both this bean and the dog class are not tightly coupled to each other. Now although we accomplished dependency injection, our main class logic is not intended to manage the dependencies in our application. Now imagine that you're working on a real-world project and you have thousands of class files. It's really messy to manage all the dependencies from your application logic itself. Instead, it would be wise to leave that task to a third-party tool, and the tool that I'm talking about is, of course, Spring Framework. So let us see how we can leave that task of dependency management to Spring Framework, because Spring is designed specifically for that purpose. Well, in fact, Spring is just not meant for dependency management, but a host of other stuff, which we'll talk about in coming videos. Hope it makes sense. See you soon. Okay, let us take a look at how we can perform dependency injection using Spring Framework. Download the project that is bundled along with this chapter and import it into your workspace. I believe we already have a video demonstrating how to import Maven projects into Workspace. Just follow those instructions and import the project. After which, you should be able to locate all these files inside the project. And before we move on with the dependency injection, let us try to import certain libraries required to perform this job. And the libraries of interest are Spring Core, which will provide all the core Spring functionalities, and Spring Context, which will help us create the Spring application context. We'll understand what is application context in a while. Well, ideally, it's not required that you need to specify Spring Core library in here, because Spring Context is dependent on Spring Core. So even if you don't specify it, Maven is actually going to take care of downloading Spring Core because Spring Context is dependent on it. And once you do that, just right-click on the project, go to Maven, and click on Update Project. Only then will the Maven look for all these libraries in the internet and download them into your local repository. Once you do that, you have to create an XML file. You can give any name of your choice. In my case, it's with the name config.xml, and this XML file must reside under the resources directory. And this is the XML file, which is a key file where we would define all our classes. In the eyes of Spring, every component or a class is called a bean. So we just simply defined all the beans that we're going to work on, and here is how you would define them. I've specified the class name, which in this case is dog, and I have given it an identifier with the name animal. Similarly, I've also defined our bean in here, including its package, and then I've given a unique name to it. Along with that, I've also added another tag in here, which basically the constructor argument that this bean accepts. So it's going to accept a argument of type animal, and it's the same thing that I'm trying to do in here. I'm trying to send a bean with identifier animal, so that points to this dog class, which of course implements the animal interface. Now earlier in our main class logic, this is how the code was. We've explicitly specified the dependent class like so, and then we're trying to call the method. But this time we're going to do things differently. We're going to use Spring, and this is how it is done. We're going to create an application context, and what application context essentially does is it would just simply parse through the XML file that you specify in here, and it would take a note of all the list of beans available. And when you run this program, the application context is actually going to create instances of all these classes and then inject the dependencies. In this case, the bean is dependent on the bean animal, and so application context is going to take care of injecting animal into this bean class. And right after that, we're going to use this object context to get the bean of your choice by using its unique identifier. In this case, we're interested in getting this bean class object, and then we're trying to call its method shout, and that would result in executing make noise of animal, and whichever the class that we're trying to inject from here, its corresponding method would be called. It's as simple as that. So if you run this program, this should ideally call the shout method of dog. It worked. Now let us change this to cat. Save the file and run the program. And it worked as well. Well, I'm actually trying to keep things simple for now, but we will go deep and understand what is application context, what is wiring, what is inversion of control, and all such concepts would be coming in future videos for sure. But I hope that this chapter has given you some good start. But make sure that you're able to run this program successfully on your own If you face any issues, do put your question and then I should be able to answer it. But please don't go further unless you get this application working, because this is your first crucial milestone. Alright, see you soon.